So I'm gonna compare the async IO versus Goroutine, which is a lightweight implementation of concurrent task completion in Go language. But first, we need to start with the Python async IO and see how task can be completed concurrently. By task, I mean 2 tasks or more. Okay, let's start with Python first and see how it works. So bear in mind, I'm going to compare them with the time elapsed of execution, the amount of time it will take for those tasks to be completed. To start with Python, let's create a Python script. We are going to name that async Python py, and we are going to use Vim to edit that. We need to import the async IO. The async IO is the Python module responsible for emulating concurrent task completion. Using a loop, it's gonna implement the loop design where there is an environment where task has to run concurrently, right? By task, I mean mainly a function, because a function is a first class type in different languages, because, you know, from a function that's a lot of classes being deducted from. Okay, so we are going to import the async IO, and now we need to create 2 tasks. The first task we are going to create, we're gonna name that, let's name that compute. Compute will receive a string. Let's name that paragraph. It's gonna be of type string. Okay, and then we are going to declare a variable. We are going to declare a variable. Let's name that C of type int dot 0, and we're gonna create a loop for I in the range of so let's create the range. Maximum will be the length of our string, the length of instead of saying paragraph, let's just say string, you know, or param. Let's just make it param so it can be shorter. And we are going to raise the length of param to the 4th. And we increment our C int to I times 2 to the square of the index of each character from the string or parameter. And after completing everything, we can print the sum of each character, char, which is character squared of the length of paragraph to the 4th, and we pass C. Okay, that's our first async function. The async function return any variable, which means it's going to be executed, you know, with deferred. The results will be deferred. The second task we are going to create, we'll name that sleepy function. This task, sleepy function, will mimic the memory intensive operation IO, read and write. So we are going to import random, and let's pass the delay. So the sleep random dots, we run random within a maximum second. The random number of delay will be maximum of 4 seconds. And we're going to print sleepy funk, go to bed. Sleepy funk sleeps for, we pass the delay, or the delay will be of type float. So this one will be of type float, so we need to format the type float to 2 or decimal position second. Okay, now we await a async IO sleep function, which sends this function to sleep for a couple of seconds, and we print something like a sleepy function awakes. Okay, so we got our 2 tasks, one that computes, some summation of square of x number, ranging from I to the length of your parameter to the 4th. Okay, and if name, we need to run these 2 functions to our main, since we are creating a script. Is main, meaning that if the module is main, parameter or param, let's name that paragraph. We're gonna receive inputs from the user, right? So we want to make sure the user will insert something. Inputs, enter your paragraph. Remember, what we're receiving here, we're receiving only a string of characters. We're not gonna accept our space, our special character, to make it simple, right? Because we don't want to get the Unicode, the UTF string. We just want to get a bunch of characters. And we print the results. So we want to compute the amount of time we will take for these 2 tasks to be completed concurrently. So the results will be results equal time it. We are going to use time it module. So if we need time it, we gotta import time it, import time it. Time it is a part of module that enables computation timing, right? If you pass a function as an argument in time it will retain the amount of time it took for that function to be completed. So we are going to use time it, and then we call time it function. We are going to pass our function we need to run. We are going to run both these tasks, sleep funk and compute funk. To make it easier, we're just gonna run the sleepy function so we can see how these 2 tasks, can work concurrently. Okay, so we are going to wait sleepy function right here, and we see what's gonna happen. Right here, we are going to call only the compute function, async IO run. So we are going to use the run method or the run function in async IO, which is a transient loop. So the run will create a transient loop, a loop that will run, that will be created, run the async function, and delete itself once the task is completed. So run compute, we run our compute and we pass the parameter. The parameter will be passing gonna be the paragraph, the one that the user has entered. Right, so to pass that, we are going to use the string format, and then we pass paragraph. That's the function that time it has to run, and the results of this will be the amount of time in seconds, right? The amount of time it took for this function to run in seconds. The second argument, we need a setup. A setup is what needs to be true for this function to run. So for asyncio run to run, we need to import from main. Remember, the timeit doesn't know the context. So we have to define the context from which timeit will be run. So we need to import this asyncio within timeit. From main, import asyncio. We also gonna import the paragraph, and we also gonna import the compute this function. And the last argument, we need to tell timeit the amount of time we want this function, the compute, to run, just once. Okay, and then when after it's run, we need to return the amount of second it took for timeit to run this function. It took for Python basically to run the two tasks. Tasks have been executed in we want to use the microseconds. Task has been executed in microseconds. We could have returned that in seconds, but in seconds gonna be a bunch of decimals, so we need to convert the decimal number to a microseconds, which gonna be the number of seconds times 10 to the 6th, which is the microsecond, right? We format results. These results will retain the amount of seconds, right, it took for timeit to run, for Python to run the compute function. Result time 10 to, or we could say something like as 1 million, but let's just do it like this so it can make sense. 10 to the 6th. Okay, so we got two tasks. One encapsulates the other one. We have a sleepy task which mimic, or emulates a task, that does some IO, read and write. So we have a sleepy task and a compute task, that's loop, creates a loop of bunch of okay, and compute them. Let's write an exit. We can try Python asyncio Python. We got error somewhere. We need probably to close something. Async. So we need to close. Let's convert this to int. Right, so we can convert this to int and close that. So we are converting the length of our sentence or string to int. Python async. Okay, so let's say something like a some string, and that's our sleepy function. The sleepy task sleep for 1 second, and then it wakes up, and then this is what the task, this is what we get, and this was the amount of time it took for us to, in microsecond, right, 1000 something, 191,000, is that 1, 2, 3, 1, 2, 3. Oh, it actually took a long, right? It took some seconds, you know. This is probably 2 seconds. If 1, 2, 3, 4, 5, 6. So it took 1 second, pretty much the amount of this sleep. So the sleep kind of like increase the task, right? It makes it a little bit longer. Isn't it crazy? Let's try again. I'm gonna try a string, something like this. Now this time we can see it took a little bit, you know, couple seconds. I mean, not close to a second, because this is 511,864 microsecond, which is the pretty much half seconds, right? The half second to complete. So what's happening here on this compute function, we take the length of this string. We take the length of the string and we raise that to the 4th, and we loop from 1 to the maximum number. And when we are looping each one of the character, we are squaring that, we are raising that to 2, and we increment, we create a summation. Okay, and this is the amount of second. It's not really a second. I think the sleep is kind of like a condition, how long it's gonna take for this function to be complete. What if we remove the sleepy function? What's gonna happen? Let's say we remove the sleepy function, right? So it looks like the amount of time it will take for the compute function to complete. It's kind of like it's dependent of the amount of time it takes for a sleepy function to be completed, a sleepy task to be completed. So I'm gonna remove the sleepy task, right? I'm gonna comment that out. We no longer have a sleepy task, and let's see how long it's gonna take for this task to be completed. Now we have 1,268 microseconds for this loop to be completed, right? So we raise 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we raise 10 to the 4th, and then we square each number. We square them, and then we sum the results, and this is gonna be the results. You know, some computation just to make it, you know, mimic something like you know, we are using memory intensive operation IO, you know, and that's what we're gonna get. And keep this number in mind. Now we are going to use the Goroutine in Go language and see how long it's gonna take to compute a similar operation where we have a Goroutine function that will receive a string, and we get that string, the length of that string, we raise the length of that string to the 4th, and then we create some summation on each number. Okay, now let's run the Python again. I'm gonna try with my name. As you can see, we get 854.26 microsecond. If we enable sleepy function, let's make sleepy function to go to up to 8 second random. I'll try my name again. It's only sleep for, you know, dots 73 seconds. Let's try again. 1 second. Now it looks like the sleepy function determines the amount of time it's gonna take for this compute function to be completed. Let's create now a Go routine that execute concurrent task, right? and see how long it's gonna take for Go to complete that. The same scenario. We are going to call that neo-vim. Let's call that Goroutine.go. Let's start with the package. The package is gonna be main. We can import the format. I don't know. I think it's the format package, a module. What else we're gonna use? We're gonna use the time because we need to compute the amount of time it will take for these two tasks to be complete concurrently in Go. We're gonna create our, listen, see, I'm about to say dev func. Let's create our task. We name that compute. Compute will receive a paragraph. Let's just call that param of type string. It's not gonna return anything for I in the range of let's say int. So we're gonna get the length of the param. Let's call that max number. Int of length of param. Okay, or if we want to raise this to the fourth, the way we did in Python, we are going to import the module math, right? Let's import, we don't need comma. We're gonna import the module math, so we can raise that to the power of so we are going to say math, right, to raise this to the power of the length of param to the power of fourth. Now if we do this, it's gonna throw an error because the function power of in Go only receive floats 64. So we gotta pass float 64. We gotta convert the length to float 64. And the default 4 will also be the, by default, when you pass the int, it will convert that automatically to float 64. Okay, we range to the max number, the same we did with Python. Of course, we don't need to forget our total or our C. Let's name that total C var C int or total or sum. It's gonna be int. We declare with the initial value of 0, and we increment our sum of each element square, the square of each element, the square of each value or each character from 1 to the power of the length of parameter to the fourth, right? You know what I mean. And then we are going to print length, the sum of each character square to the fourth of your string or param length, and we pass the sum. That's our first task, and this is our main function, func main. We are going to define the string where the user inputs will be passed into. var param string. We can print, enter your paragraph. Remember, a paragraph in English, it's, you know, a composition of words with space and special character, but I'm just saying a paragraph here, but practically it's a string. We don't want to use buff IO so we can get space and Unicode, and it's gonna take long. We don't want to do that. We're just calling that paragraph, but technically it's not paragraph, it's a concatenation of characters, basically ASCII character. Okay, and then we need to receive scan. We are going to use scan new line, which scan everything except the new line parameter. And we are going to start our code or execution time using time function now. And the next thing we need to do, we are going to run our task. So to run a Goroutine task in Go language or Golang, you just run your function with the prefix Go. So the prefix will be Go space, and we're gonna say compute, and then we pass the param. Okay, and then we're gonna run another task as a closure, right? Go func, let's say message, it's gonna be of type string. This one is also a Goroutine, and let's just this we print format sleepy function task completion, right? Let's just say something like a sleepy task has been or sleepy task just wakes up, something like this. Yeah, just message. A message will be wakes up, and then we're gonna call this function with the argument will be wakes up. Okay, once our second task run, now we are going to capture the elapsed time since the start, and we are going to print formats. Sometimes I do use print formats. I kind of like it because it comes from C, or I use print S. It depends. Function task have been executed in we pass the string new line elapsed time, and the elapse will be the time completed in microseconds. Now second microsecond by default. Okay, now let's go run our task. Go run Goroutine. There we go. So if we type something like my name or some random string, as you can see, it's only took Go 13 milliseconds to run the computation, right? Computing like a raising the length of 1 2 3 4 1 2 3 4 5 6 7 8. So raising 8 to the 4th, and they're going to a loop on each one of the character, raising that to the square of each x, and doing the sum of the square of each sum. So which is like the sum of each car squared, each character squared to the 4th of your parameter length is XYZ. But guess what happened? If we run it again, you can see we are skipping the sleeping function, right? And also you notice that the amount of time in microseconds has increased. If you run it again, still, I mean, the longer your string, the longer your task will be completed. I mean, the compute task. But what we're missing, the sleepy task is not running anymore because the execution, it's really random. The compute doesn't need the sleepy task to complete. If sleepy task, if the compute complete its task, it just prints directly, right? To make it work so that we can capture the sleepy task every time we run this function, so that both of them can run, we can use the work group module in Go, right? Which allows us to define how many tasks we're gonna run and make sure that each one of the tasks added to the work group and run them concurrently, right? So the Go work group module kind of organize your task together. Okay, so we need to modify our code. The first module we need to import, if not a package, we are going to import the sync module, and we're gonna initialize our work group var work group is of type sync weights group. Okay, so we create a work group where each one of the tasks will be added. What are we gonna do with work group? We need to use work group, right? To use work group, we're gonna use him to add the amount of tasks we are going to run in the work group. Okay. Once we start our code execution, we run group. We tell work group we need 2 tasks that will be run concurrently, and we add 2 tasks. After adding, we are going to pass the work group as an argument in our compute, which means our compute function or our compute task or Goroutine signature should change. So we pass him as a argument, but we're not gonna pass him by reference. We're going to dereference our work group and we pass him. And right here, we are going to receive our work group. Work group will be of type pointer. It's gonna be a pointer to a work group. Right, async awaits group. Okay. Now, to make sure that our 2 tasks will run concurrently, we want to make sure we wait both of them to be completed. What we need to do first, we're gonna tell this task A, we want you to defer task completion. Work group done. So we defer task completion, which means once this task is completed, we tell A, once complete, wait. We're gonna tell you when to return the response. So we defer task completion, but we also have to defer task completion on this Goroutine that's run as a closure. You're also gonna say right here, defer work group done completion, meaning that we are telling this Goroutine we will only get your results when all the tasks are completed, when we need you. And this is where we need to wait for them. Before we print, we say, okay, now we are ready. Now we are ready to get your results. We are going to wait for your here. Once you're completed, tell us that you are completed. Okay. Now let's run Rogan. Let's run Goroutine. If I say something like as you can see, the sleepy function just wakes up and the task has been executed. Both of them has been executed in 33.484 microseconds. Way much faster than Python. You might be saying something like about you make the sleepy function in Python sleep, right? Why don't you make the second task on go to sleep as well? Where I can do that, I can make the second Goroutine function task to sleep right here. I can say something like time sleep, let's say 3 seconds or 4 seconds times second. Okay, so we are telling the sleepy function, hey, you can mimic, AV computation, memory bound AV computation, something like you're reading files or writing on files for 3 seconds. And let's see what's gonna happen. We type something, it goes to sleep, sleepy function sleeping, and then when it wakes up, you can see sleepy function was kind of like working on its own. As you can see, it's even faster, right? So you can, judge and make your conclusion which one ran faster between the async IO on Python and the famous Goroutine in Go, right? You have the answer. Obviously, as you can see, the Goroutine ran way much faster and it's more efficient than the async IO in Python. Now, you might be wondering, but you like programming on Python, so what are you saying? Are you saying that you're gonna decide stop programming on Python? Well, I've been coding with Go for a couple years, some of the side projects, and but I still like Python. I've spent a lot of time with Python. I see program with Python. It doesn't mean that Python is the best language, but Python has just bunch of tools, bunch of predefined functions. Go is more efficient, but it doesn't have a lot of module and a lot of function, pretty handy function you can use, right out of your toolbox, to complete tasks. So, but Go is way much faster, we all know that. But, I just wanted to compare the two light way, the two modules that implements concurrent task in both languages. I mean, in Python comparing to Go language. That's all for this video. Thank you all for watching, and I'll see you in the next one. Bye-bye.